Alright, it's recording. So let's do a bit of recap just so we can revise our unit circles again. Here we go. Yesterday we talked about a unit circle. Here's your picture. Here's x axis, y axis. That path of the unit circle, every coordinate along that point, that's what you're studying. Unit circle means that, thank you, please don't speak while I'm speaking, that you have a unit length of 1. So this is what we were saying yesterday. So unit length of 1, that means everything is 1. This is now -1 over here. This particular point on the circle is then -1, right? Then I introduced you to first exercise was radians and degrees. Now let's recap your memory. The distance around the entire circle is how much again? What was the distance, Damafi? You do one full revolution, 360 degrees is equivalent to 2 pi. So that's radians. Okay, radians is the measure of the distance outside. And if you've forgotten how to do that, just do C equals circumference equals 2 times radius times pi. And since the radius is 1, that's why you end up with 2 pi. Okay, so the full distance, I'm going to draw a quick circle just to remind you, the full distance around this one revolution is 2 pi. So that means 2 pi is here, but remember you always start 0 there. So the distance, you start at 0, so imagine I had that line there. You start at 0, and you always go anti-clockwise. Okay, anti-clockwise. Now, notice the circle split up into 4 little pieces. What's the first place called? What's this one called again? Quadrant 1. Okay, so it goes Q1. So I say Q1. Then because we're going anti-clockwise, Q2 is over here. So this is Q2, Q3, Q4. Okay, so yesterday I taught you, all right, unit circle. We know that it goes, all full revolution is 2 pi. But then what happens if you go half a revolution? What if I only went from here to here? How far is that? How far is that? Can I please have Anthony? How far would that be? Pi. Very good. It's 1 pi. And logically, full distance is 2. So then half a circle must be pi. The benefit of knowing that that's pi is that you start to see a pattern. It goes 1 pi, 2 pi, 3 pi. So I'll write it over here. 3 pi. Then it becomes 4 pi over here. You see, every time I move, so this is 1 pi, 2 pi. Whoops. 1 pi, 2 pi, 3 pi, 4 pi. And then you end up seeing a pattern that if you follow, becomes pi, 3 pi. The next one must be, what's the next one? So this is pi, then it becomes 3 pi. What's the pattern? They're becoming 5 pi. It's all the odd pies. This is why we like working in radians, is because it's easy to figure out, because all the odd pies will end up here and all the even pies will end up over here. Okay, so 6 pi, etc. Then I explained to you the coordinates. So I picked out a point. When you make a certain angle, see if I rotated anti-clockwise by a certain degree, I land at this spot. At this particular spot, it must have an x and a y coordinate. Okay, so that point there has an x and a y coordinate, and I showed you that you can actually see a right angle triangle that occurs. You get this radius of the circle, which is 1. And notice that when I draw a vertical line down, this is your y coordinate. That's how high you go versus how far you go. So if I draw the triangle out, you get a right angle triangle. This is y, theta, x, and 1. And then from there, we use SOHCAHTOA that you learnt in year 9 to remind ourselves what is x and y equal to? I showed you yesterday what x and y equals to. What does x equal to again? Can I please have Artie? What's x equal to? Cos theta. For those who forgot why this was true, remember back in year 9, cos, SOHCAHTOA, is adjacent over hypotenuse. But notice the adjacent, that's x. Hypotenuse is 1, because that's a radius of 1, right? Unit circle is length of 1. So really, it ends up being x over 1 equals x. That's why we say x is equal to cos of theta. It means every time you type on your calculator cos of any angle, you're really just finding the x coordinate around the circle. Okay, so no matter what the angle is, whether you rotate it 160 degrees, cos of 160 just tells you the x coordinate of that point. If you did cos of 210 degrees, then it just tells you the x coordinate. That's what cos does. Cos just tells you the x coordinate. Okay? And then similarly, what is y equal to? Y is equal to what? Let's go with Lillian. What is y equal to again? Very good. It is sine of theta. And again, you can prove that by doing the same thing again. Opposite over hypotenuse, and it becomes y over 1. That's why you have that. So every time you type sine of the angle, it just tells you the y coordinate around the circle. And the last one I mentioned, which was in your previous notes, what is tan then? So we've got cos, we've got sine. Tan. What is tan equal to? It's the gradient. And remember, gradient is rise over run. But notice, when you say tan of theta, it's opposite of adjacent. But in that triangle that we just drew before, opposite is y, and adjacent is x. Y over x is your rise over run. That is why tan over theta tells you the gradient. And so that means, no matter what the angle is, if I rotated, let's say, 280 degrees, at that point, when you say tan of 280, you're really just asking, what's the gradient? And you can already see the gradient's negative. That's a negative gradient, positive gradient, zero gradient, undefined gradient. So that's what these three functions represent in a unit circle. You get that from yesterday? That's the first step. Then I showed you ASTC. So a lot of students memorize this. A, S, T, C. I didn't want you to memorize ASTC because logically you can all tell me just by looking at the unit circle. So I'd rather that you actually just read the unit circle. But here, all these ASTC just stands for is the x, y, or the gradient positive or negative. That's it. If I had to pick a point, let's pick this one over here. So I pick one in quadrant 2. If I asked you x, y, and the gradient, at this point, logically, without even knowing ASTC, at this coordinate here, is the x positive or negative? It is negative, just by looking at it. Clearly at this point, that's on the negative x-axis, so it's negative. Y, what's the y value? Positive or negative? Positive. And then finally, now if you think about the gradient, if I just connected back to the origin, because that's how far I had to rotate. I had to start from here, 0, and I rotated there. What kind of gradient is that? That line. Is that a positive, 0, negative, or undefined line? What kind of line do we have? Negative. So you didn't need to memorize ASTC because I just picked a point and I asked you some basic questions there. But the reason why it's S is because Y represents sine. So they're just saying sine is positive in this region. If you followed the same thing, this just means tan, the gradient is going to be positive in this region. C stands for cos is going to be positive in this direction. It just means that all the coordinates here, only x is positive, y is going to be negative, and the gradient's negative. So you don't have to memorize ASTC. You're literally just reading the unit circle. So with one picture, I have summarized what you needed to know for ABC. And that's the foundational theory for chapter 14. Okay? Now, let's practice your understanding of unit circles. So here we go. Let's practice this. Look here, unit circle. Picture it in your head, or I'll draw it on the side over here. Here we go. Here's a unit circle. Let's picture it. When I say sine, what is sine representing again? X, Y, or the gradient? Which one is that? Let's go with Milena. Is sine X, Y, or gradient? Well, I was just saying, so when you say sine, are you looking for the X coordinate, the Y coordinate? The Y coordinate. So sine represents the Y coordinate there. So you're looking for the Y coordinate. When we say, what is sine of 180? The question's actually just asking you, what is the Y coordinate when you have 180 degrees? So, here's 0. You rotate 180 degrees. Here we go, I rotate 180. So if I use the pen here, rotate 180. This is where I'm sitting at now. I'm sitting right at this point. Now at that point, you're asking, what is the Y coordinate at that point? So look at the diagram. Don't try to overthink it. Just literally look at that point. What is the Y coordinate at that point? 0. That coordinate there's a unit length of 1, so it must be -1, 0. The Y coordinate is clearly 0. So when we say, what's sine of 180? The answer is 0. That's all it is. You're not doing anything more complicated. You're just reading the X, Y, and gradient coordinates. Do the next one. Cos of 3 pi on 2. Now, for those who haven't yet understood radians yet, 3 pi on 2 is 270 degrees. So try to rotate in your head. I'm asking, cos. Cos represents the X coordinates. I'm asking, what is the X coordinate after you rotate 270 degrees? Where's 270? Here we go. I'm going all the way, that's 180. 270. So I am right now at this point. What is the X coordinate at that point? So what's cos of 270 degrees? 0. At that point, that is 0, -1. So if I ask what the X coordinate is, it's 0. Tan. 5 pi on 2s. Now, eventually I do want you to be able to work with radians, so pi's on 2s. So just to help you understand it, in your diagram, when you draw a unit circle, put some radians in. So you already know 2 pi's here, you know pi's there. So if pi's here, then half of a half circle is then a quarter. So then this is pi on 2. But then notice the pattern. This is 1 half, 1 whole, plus another half is 3 halves. Then you go here, that's 4 halves, then this is 5 halves. So you start to see a pattern. It becomes 1, 3, 5, 7, 9, 11. Okay? So when I ask you, what is tan of 5 pi on 2? 5 pi on 2 is literally going to end up at this spot. You're going to be right here. That's where 5 pi on 2 is. So when we say tan, see, cos is X coordinates, sine is Y coordinates, tan is the gradient. So I'm asking, what is the gradient at 5 pi on 2? So looking at my pen there, what's the gradient at 5 pi on 2? Not 0. 0 is a flat line. Undefined. Vertical is undefined. So this is undefined. Last one. Cos of 2 pi. So now I want you to think about it. Write an answer first. Write an answer in your head. Cos is the X value. So I'm asking, what is the X coordinate when you're at 2 pi? So where is 2 pi? And then what is the X coordinate? What do we have? What do we have, Artie? 1. So if you got 1, well done. If you didn't, that's the area you want to work on. So what I just did just now, that's a recap of the theory for chapter 14. Today, I'm going to teach you to memorize these values. So what you've got here is the key points. 180, 3 pi and 2, 5 pi and 2, 2 pi. You're really just working on these axes. But what happens if you're in between? So 45 degrees, 30 degrees, 60 degrees, and 90 degrees. There are special angles for you to memorize. You only need to memorize the acute angles of 30, 45, 60, and 90. There are 5 numbers, which conveniently you have 5 fingers as well. So I'm going to teach you on the next page, it's called the hand method. I'm going to teach you to memorize all 15, because it's 3 by 5, all 15 times tables within about 3 minutes. Okay, so you'll be able to learn it and memorize it. There's a lot of different ways to do it, but this is how I do it with my students. And when I see in the exam students using their hands, I know they've learned their hand method. Okay, so here, how does the hand method work? So you need to remember all these values here. So if I asked you, what is sine of 30 degrees? You should be able to tell me half. Sine of 45 is 1 on root 2 or root 2 on 2. Sine of 60 is root 3 on 2. You have to memorize all of these. So there's many ways to do it. You can do the proof. You can do an actual proof. Here's the proof. Equilateral triangle. If this length is 2, that's 2, that's 2. Right? That means if you cut it in half, this is 1, this is 1. So based on this right angle triangle, you know this is a length of 1, that's 2. How do you find this height? What do you do to find this height again? How do you find this height? It is the opposite side depending on where the angle is, but you've got a triangle. You've got a triangle, it's right angled. What technique have you learnt to deal with right angled triangles? You got Sokotoa and Pythag. Here's your C, here's your A, find B. Use Pythag to find that height. Now if you were to use Pythag, it is C squared. So C squared equals A squared plus B squared. So you got 2 squared is equal to 1 squared plus, and you don't know what this is. Solve it. 2 squared is 4. 1 squared is 1. So, minus 1 on both sides. Therefore, B is equal to root 3. This is root 3. Now, if you do that, you can see where they got the exact values from. Sine of theta is opposite over hypotenuse. So if this is my angle, say that was my angle, opposite over hypotenuse will give you, well, sorry, we do know the angle in an equilateral triangle at 60 degrees. So this is 60. If you half the 60, that's 30 there. So that's why they know sine of 60 degrees. When you say sine of 60 degrees, 60 opposite over hypotenuse, that's why it's root 3 on 2. But if you did sine of 30 degrees, well, 30 degrees here, so the opposite is over here, so it's 1 over hypotenuse. That's why it's half. So some students like to use these triangles, so you can do the isosceles version. You can do an equilateral triangle in your notes, and then you'll be able to remember all 15. But I personally still find that takes long. That you still have to work out these things before you know it. So I like the hand method, but I do know some other students use that method. They prefer that. Okay, so it's up to you. I don't care. You just need to know all 15 exact values. So at the end of this week and next week, I'm going to keep testing you. So I'll call out your name, and you need to know sine of all 5 values, 5 angles, cos of all 5 angles, and tan of all 5 angles. Okay? So if you followed that, that's how they get it. So 30, 60, root 3, 2, 1. That's how we end up with cos 60, sine 30, and tans. You can do tan with it as well. Okay? All right. Isosceles triangle is the same thing. Isosceles triangle is saying that, well, if that's 1 and that's 1, unit length of 1, 45 degrees here, then that must be 45 as well. Using Pythag, this should be root 2. 1 squared plus 1 squared, and then square root it. And then that's how they get sine of 45. So when you do sine of 45 degrees, well, it's 1 on root 2. That's where they get that from. Okay, and if you do tan of 45, opposite of a hypotenuse, opposite of an adjacent, that's why it's 1. Okay? So you can get all 15 through these 2 triangles, isosceles or equilateral. Or if you flip over the page, I'm going to show you a quick way in 3 minutes. You're going to learn all 15. Okay? Here we go. Flip over the page. I'm going to show you the hand method. You can use it, take it or leave it. I don't care. Here we go. Back then I used to get my students to draw on their hand, but you don't have to. It gets a bit messy. You just need to work from left to right. So I don't care if you're a left-hander or a right-hander. The point is, whether your thumb's here or your pinky's there, it doesn't matter. You're going to move from left to right. So from left to right, it starts off with 0 degrees. Pi and 6, you got to get, I put radians because you have to know radians eventually. The degrees helps you to understand. The radians is what you're going to work with. So the angles increase. So pi and 6 is actually 30 degrees. Then it becomes 45, 60, 90. Those are our special angles. Yeah? Notice the radians actually goes the other way. So as the degrees increases, the radians decreases. 6, 4, 3, 2. Yeah? 6, 4, 3, 2 versus 30, 45, 60, 90. And it makes sense because if you divide by a very large number, it gets smaller. Yeah? So the smaller the number that you divide, the larger the number is. Yeah? So 180 divided by 2 versus 180 divided by 6. That's why it makes sense. Yeah? All right. How does the hand method work? So if you've got the 5 fingers and you know what each finger represents, here's the formula. This is square root of a number of fingers that you're going to be counting soon, and then you divide it by 2. So you halve that. So square root the number of fingers and then divide by 2. So which fingers are we working on? Notice the signs on the left, cos is on the right. Yeah? This is how it works. Let's say I want you to find cos of pi and 4. Right? Actually, I'll do something else before that. Let's say I want you to find sine of 30 degrees. Let's do that one. Which one's my 30-degree finger? Index. So I'm going to cross this one off, which means you drop it down. Notice there it separates 2 sides. There's the left side and there's the right side. Left side represents the number of fingers for sine. Right side represents the number of fingers for cos. But I'm looking for sine. So how many fingers for sine? 1. Now the formula says, count the number of fingers, square root it. So what's root of 1? 1 and then half it. So 1 divided by 2 is half. So the answer is half. Let's do another one. Cos of, let's go with pi and 6. Same thing. Pi and 6, which one's that finger? Same one. So I drop this one down. How many cos fingers do you have? You've got 3. So it's cos is on the right. So I've got 3 fingers for cos. Cos of pi and 6. We've got 3 fingers. So the first step is square root the number of fingers divided by 2. The answer is root 3 on 2. Let's do another one. Let's do cos of pi and 4. So you got to know which one's pi and 4. Pi and 4 is 45 degrees. Which one's my 45-degree finger? Third one, the middle finger. So cross this off, drop it down. Now I'm looking for cos. How many fingers for cos? 2. So the formula is square root the number of fingers, so I got 2 of them, and divided by 2. The answer is root 2 on 2. Or 1 on root 2, same thing. But with just that, if you understand that formula, you already memorized 10. All 10. So I can ask you sine of 0, sine of 30, sine of 45, sine of 60, sine of 90, and you use the same formula to get them. And cos of 0, cos of 30, cos of 45, cos of 60, cos of 90, and you would have got them. The only thing you're going to be careful is just the last ends. So let's test your understanding. What if I said cos of 90 degrees? Which one's my 90-degree finger? Yeah, in my case, it's my pinky. So if I drop it down, it means I'm going to cut this one off. How many fingers do I have on the right-hand side? No, this is the left-hand side. I've got 4 for sine, but how many for cos? 0. Unless you have 6 fingers. Okay? Most of us have 5. So there's 0 fingers on this side. So how do you do it? Same thing. Square root of 0 divided by 2. Well, what's root of 0? No, root of 0 you can't do. No. 0. 0 times 0 is 0. So hence, square root of 0 is 0, but 0 divided by 2 is 0. Now, the only time it's undefined is if you divide by 0. So if 0 is on the bottom. Okay, you can always do, if you have $0 and you want to share between two people, both people will get $0. But if you had $2 and you don't know who you don't have any friends to share it to, you don't know how much you're going to share it for. That's why it's undefined. That's why you can't divide by 0, but you can divide 0 by whatever number. Okay, it's got nothing to give. Yeah? All right, so what I just showed you there with just the one hand method, one rule, you can learn 10 out of 15 just from that. So all you have to memorize, not the numbers, just angles and a formula. Yeah? 5 fingers and a formula. So how do you do the next 5? This one I made up and it works. This one over here you can find on YouTube. Most people will teach that one, but they don't teach this one I made up. Okay, so this is a special Mr. Tran version. Same thing, everything's still the same. 0, 30, 45, 60, 90. Angles are the same. The only thing I'm changing is the formula. Now it's easy to remember this formula because remember tan is equivalent to opposite of adjacent, right? Tan is opposite of adjacent, but you told me before was y over x. And y represents sine and x represents cos. So sine over cos. Yeah? So this is how it works. Tan of pi on 6. Let's do that again. Which one's my pi on 6 finger? Index. Drop the index down. So now you've got a sine side and a cosine side. So the formula says count the number of fingers for sine, divide it by the number of fingers for cos, and then square root the answer. So let's do it. How many fingers do I have for sine? How many fingers for sine? 1. How many fingers for cos? How many fingers for cos? If you drop this one down, how many cos fingers? 3. So you got 1/3, and the final thing is just square root it. But if you square root it, can you square root 1? Yes, you can. Root of 1 is 1. What you can't square is 3. So the answer is 1 and root 3. Let's do another one. Let's do tan of pi on 3. That's what I asked Ishan before. Tan of pi on 3. So let's do this one. Pi on 3 is your ring finger. Here's your ring finger. Cross it off. Count the number of sine. Count the number of cos fingers. How many sine fingers do I have? How many sine fingers? 3. Divided by cos fingers? 1. So 3 divided by 1 is 3. Right? And then square root it. Just root 3. Okay? How do we feel? Pretty good? The only one you got to be careful of, the end ones, the zeros and the 90 degrees. So let's do the last fingers. What if I asked you, what is tan of pi on 2, which is 90 degrees? So you cross off this finger. Now, go through the motions. How many sine fingers do we have? Good. How many sine fingers do we have? We've got 4. How many cos fingers? 0. So 4 divided by 0 is undefined. Okay, 4 divided by 0 is undefined. So already, even if you square root it, it's still undefined. If you understood that, there was only 2 formulas, 5 angles to remember, and then you'll know all 15. Okay? All right, once you got that, copy that down, copy those 2 formulas down, get used to the idea. I'm going to teach you one example so that you can then apply your understanding. Okay? Here we go. Let's apply. Can you scroll down? You can answer these questions yourselves. Okay? Let's go down to the very last 2. Example 2. Let's do this one. Here we go. Yesterday's session. Shh. Quiet down, thank you. Sorry, Year 11s. Thank you. Please don't speak while I'm speaking. I'm doing the last example. This last example ties in what I was kind of introducing yesterday. I was introducing yesterday why we use radians and not degrees, right? 5 pi on 3, the problem is you don't know where it is yet. So yesterday I taught you a way to figure it out. Here we go. 5 pi on 3. So you've got the denominator as 3's. What two numerators can you come up with to make this a whole number? Because remember, we like the whole numbers. All the odd ones end up here, and all the even ones end up here. So I just need to figure out which one is 5 pi on 3 closest to. So we've got 6 pi, so this is 6 pi on 3. What's the one before? 3 pi on 3, because we're going by the 3 times tables. Yeah, so you got 0, 3, 6, and then 9, 12. So clearly, when you look at 5 pi on 3, this is equivalent to 1 pi. This is equivalent to 2 pi. So where's 1 pi, 2 pi? Here's 1 pi. Here's 2 pi. So you're either in quadrant 3 or you're either in quadrant 4. But clearly, 5 pi on 3 is just missing 1 extra pi on 3 to make it a full revolution. This is versing 2 pi's on 3. So from 5 back to 3, you're missing 2. So it's actually better to know you must be in quadrant 4, and you're only missing pi on 3. Now this is key. Does that make sense so far? Because that part there that I just drew is very important for you to understand. So notice how I said I was missing pi on 3 to make 2 pi. See, the 2 pi is over here. I rotated, and I'm just missing pi on 3. Just missing that bit. Pi on 3 to make 2 pi, because that's what you said. You said we're just missing an extra pi on 3, so I'm missing that distance. Now the reason why that's important is because this gives you this triangle. This triangle, this is pi on 3 in terms of radians, and this is the point. You're interested. You got an x and a y. So when you're answering the question now, you're simply asking, cos is asking for the x coordinates. So at that point, is x coordinate positive or negative? Positive. Just looking at that x coordinate clearly, it has to be positive, right? Y is negative. So the answer here, I have to have a positive. That's the first step. Symmetry properties. Second part is, see, that's a pi on 3. And your angles, pi on 3 is 60 degrees. We like acute angles. We don't want to work in obtuse angles. That's why we always have to work within these quadrants. That's 60 degrees there. Okay, pi on 3 is 60 degrees. So you're asking, what is cos? Maybe I'll change the pi on 3 to 60 to help you understand. When you say cos of 60 degrees, you're asking this length, because that's equivalent to saying cos of 60. That right there, the hypotenuse is 1. Adjacent over hypotenuse is cos of 60. That's what cos 60 represents. So I'm trying to find that value. So to know how far, what the x coordinate is, you just need to know exact values. Or, thinking about it is cos of pi on 3, pi on 6. Pi on 3, sorry. So using your exact values now, you know it's positive. What's cos of pi on 3? So think about it. Which finger is pi on 3 again? 0, 30, 45, 60. So which finger? Ring finger. So drop down the ring finger. Cos. How many cos fingers do I have? 1. Formula is root of the number of fingers divided by 2. What's root of 1? 1. So you end up with positive half. That means this length here, this horizontal length, because remember cos represents the horizontal length, that's a length of half. That means this length here, that coordinate here is actually half. That's what I'm trying to say. There. So as soon as you rotated all the way around 5 pi on 3, that x coordinate, so how far is it horizontally, that triangle should be only half distance. That's what it's trying to say. That bit there is half. From here to here is half. That's what it's trying to say. This bit is that bit. Okay? So what you're trying to do today is first figure out what is it, positive or negative, and then work out using exact values to work out the actual value. Let's do one more. One last one. Here we go. Let's start again. Sine 11 pi on 6. Same thing. I'm going to draw the unit circle. The whole exercise, the whole chapter, I actually just want you to understand the unit circle. The better you understand the unit circle, the easier it is to understand the chapter. Here we go. Sine of 11 pi on 6. Starting off the same question. What is sine? What are you looking for when you say sine? X, y, or gradient? Y. So we're looking for the y coordinates, right? We need to know where we are. Where's 11 pi on 6? So again, let's write it out. 11 pi on 6. 6 times tables. What number goes here and there? Which one is it closest to? You got 12 pi on 6, which ends up being 2 pi. Or the one before that, 6 pi. So 6 times tables. 6, 12, 18, 24. So clearly 11 is between these two. Now, which one is 11 closer to? Is it closer to 6 pi on 6, or is it closer to 12 pi on 6? Hopefully you realize that's a difference of only 1 pi on 6. This is a difference of 5 pi on 6. So out of the two, this one's an acute angle. So where's 2 pi? 2 pi is over here. That's where 2 pi is. But how short are we from 2 pi? How short are we to make a full 2 pi revolution? Well, I had to go all the way across, and I'm just short of 2 pi. I'm short of 2 pi by pi on 6. So this missing angle here, or distance, is pi on 6. See that? So I had to rotate all the way here to make 11 pi on 6, and I'm just short by pi on 6. From that position, symmetry properties is asking, or you can use ASTC, but I'm not teaching you ASTC. What's my y values? In quadrant 4, is it positive or negative? Negative. Sine, which represents y values in that quadrant is negative. But if you look at the triangle, look at that triangle, it's a right angle triangle. And you've got a distance of pi on 6, which is 30 degrees. Okay, because that distance there from here to here, pi on 6, that's 30 degrees. So that's 30 degrees, and you're looking for the y values. That's the same thing as just saying negative of sine of 30. You see that? That represents, you get y is equal to sine of 30. So, what's negative sine of 30? So you got to work out sine of 30 degrees. Use your fingers again. Sine of 30, which finger is it? Index. How many sine fingers do you have? 1. So the formula is square root the number of fingers divided by 2. Root of 1 is 1, so the answer is negative half, which makes sense. That means this distance from here to here is half. From here to here, it's negative half. That's what it means. That means this coordinate here is negative half. That's what you found out. Okay? If those two examples, you felt somewhat semi-confident, 60 to 70%, that is really good. Because that's what I want you to learn. By the end of next week, I want to be able to call out students and say, 10 of 11 pi and 6, and you should be able to tell me the answer. Okay? Eventually, you'll be able to do all of that in your head. Okay, that's the speed that you're going to work at. So first learn your exact values. There's 15 of them. And this is symmetry properties. Okay, I'm going to stop there. The worksheet I gave to you has solutions already. If you go to OneNote, it's this one. D worksheet solution. So if you want to check your answers, check it here. I'm practicing your exact values and symmetry properties. So I want you to be able to work with the unit circle. The idea is to work out, is it gradient negative? Is the x negative? Is the y negative? That's all you're doing. Okay, learn that. So you got about 20 minutes of your time. Let me know if you need extra support. But that's what I want you to learn. I'm going to stop the video here.